Hello and welcome to part two here. This is the second page of after starting on 4-2, and this is problem one representing a geometric relationship right here. And it says in the diagram below, what is the relationship between the number of triangles and the perimeter of the figure that they form, and represent this relationship using a table, words, a table, words, an equation, and a graph. Now, I don't spend a lot of time making you show me the words, but what you are going to have to do in this chapter, in this section, is be able to understand the connections between a table, an equation, and a graph. And you're going to have to be able to go from one to the other, and also identify the variables, independent and dependent variables, as we go. So let's take a look what happened. Let's pretend that here's a triangle. It's 4 here, 3, and 3. That's one triangle. Okay, and that's one triangle, and the perimeter is equal to, if we added up the perimeter here, that would add up to be 10. All right, let's take a look at these two right here. They add now a triangle. Now they have two triangles. So you have this side of 4 and this side of 4. You got 3 and 3 right there, right? So you add that up. That perimeter is 14. And then if we continue with 3 triangles, the perimeter is 18. And with 4 triangles, the perimeter is 21. Okay, so the first thing that we need to be able to do is figure out which variable is x and which variable is y. The two variables are right here, the number of triangles and the perimeter. And the question is, which one depends upon the other? As one thing increases, okay, what happens to the other one? And what they're doing here is they are increasing the number of triangles. They're adding a triangle. They had 1 triangle, they had 2 triangles, they had 3, and then they had 4. So the perimeter depends upon the number of triangles. Okay, so the perimeter depends on the number of triangles. I'll just say that. Perimeter depends on number of triangles. Okay, so the perimeter, okay, see the phrasing right here? Perimeter depends on. So the perimeter is the dependent variable. Okay, the perimeter is dependent. So the number of triangles is independent. So the number of triangles is independent. Okay, because they're just adding triangles. So and then you figure out the perimeter from that. So do you recall from the previous video which one, x or y, is independent? Okay, x is independent and y is dependent. Okay, so that means that x, since x is the independent variable, that would be the number of triangles. So the x is the number of triangles that we have. Y is equal to the perimeter based on the number of triangles. So here's x. X is the number of triangles, and y is the perimeter. Now we've already figured this out up here. With 1 triangle, we had 10. With 2 triangles, that was right here, we had 14. With 3 triangles, we had 18. And with 4, we had 21. Okay, so x, the number of triangles, is the dependent variable, and independent variable is x, and the perimeter is the dependent variable. The perimeter depends upon how many triangles you have. Okay, so as we go down here, all right, let's look at what happens. It says the perimeter is blank times the number of triangles plus blank. So we're looking for a pattern here, and if we notice that in the picture of triangles up here, I'm trying to think of how to get you to see this. This is kind of a tricky one to start you with. Notice up here they had 4, okay, in the first triangle, and then they had 3 and 3. So they had 4 and 3 and 3, which is the 6. Then here they had 2 4s, didn't they? For 2 triangles, they had 2 4s. And then 3 and 3. For 3 triangles, look, they had 1 4, 2 4, and 3 4s. And then they had 3 and 3. Okay? And then for the 4th triangle, look, for 4 triangles, they had 1, 2, 3, 4 4s. And then 3 and 3. Okay, so if the number of triangles matches the number of 4s that they had, so the perimeter is 4 times the number of triangles plus what was plus every time. See how there was always 3 and 3? So there was always 6 being added there. Now, I'm going to show you a trick here that can make your life a lot easier. I think one of the hardest parts of this section is being able to create the equation. You're going to have to be able to do that. Here's a trick. You see how I have 4, 3, 2, 1. If I continue going backwards to 0, what number, if I follow this pattern, what number would go here? Okay, 21, 18, 14, 10. It's going down 4, so the number here would be 6. You see how it matches the number that's being added? If you can figure out the 0 value, that's always going to be added. It's always going to be plus the 0 value. Okay? So that's what you're trying to do here, is you're trying to find this equation that the perimeter P is equal to something plus 6. Now, then once you have that, if you go up and you see that it's increasing 4 every time I go up, that's going to be multiplied. 4 times the number of triangles, which I'll just call x. Okay, 4 times the number of triangles, x, plus 6. And we saw it up here, right? 2 triangles had 2 4s. 3 triangles had 3 4s. So for number 8 here, the equation is P. The perimeter is equal to 4 times x plus 6. Okay, so now what we can do with all that information, you have just taken numbers from a table to an equation, and now what we're going to do is plot those points. So the points are basically ordered pairs. So with one triangle, remember x1, y was 10, and I'm right here is where I'm getting those values, right? X was 1, y is 10. For 2, x was 2, y is 14. So it's x and y. X and y. For 3, y was equal to 18, and for 4, y is equal to 21. So the last thing you need to be able to show is the graph. And we also figured out that at 0 was 6, so I could actually plot 0, 6 as well, because we went backwards and figured that out to help us write the equation. So at 0 we had 6, and then 1 we had 10, which 10 would be, what, a little bit above the 9. 2 was at 14, so that's just under 15. At 3 we had, what, 18? And at 4 we had 22, which is just over that right there. And I don't have a straight edge with me, but if you should take a straight edge, and you could see that that makes a straight line right there, and that's what we call a linear equation. Okay, so a table, a graph, and an equation, you have to be able to do all three, manage all three of those there. So that kind of wraps up that part. So again, for the sake of time, I'm going to stop this one and do one more for the last page, and we'll probably just stop after the next page. But I want to talk you through one more so that you're a little more prepared coming into class tomorrow.